Hello once again. Here we are in our Geometry 1.6 notes. Here on our first slide, we just have some basic vocabulary words we're going to talk about for just a minute. Hopefully these are vocabulary words you've heard of before, so hopefully it should be a good review. The first one is complementary angles. And you might have learned in 8th grade that complementary angles are two angles that add up to 90 degrees. And each angle is called the complement of each other. So they add up to 90 degrees. Supplementary angles, on the other hand, are two angles that add up together to equal 180 degrees, and each angle is called the supplement of each other. Down below, adjacent angles basically share a common side. Two things that are adjacent to each other are right next to each other or have something in common. Like you and your neighbor, your houses, your yards are adjacent to each other if you share a fence or share a border or property line. If you notice down here with adjacent angles, you have this blue right here as a common side, and adjacent angles will share a common vertex as well. So it'll look will look kind of like that. The important thing to remember though is that if you have complementary and supplementary angles, they do not have to be adjacent. So if we go back up to the top here, this up here is an example of complementary angles that are adjacent. They share that side in the middle. Right next to it, that is not adjacent. They add up to 90 degrees. However, they are not adjacent, but they are still complementary. Similarly, this right here, what I have circled in pink, those are supplementary angles that are also adjacent. However, right next to it, 115 degrees and 65 degrees adds up to 180. So they're supplementary, but they are not adjacent to each other. So it says to name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So take a second, pause the video, and see if you can find each of those. A pair of complementary, a pair of supplementary, and a pair of adjacent. So as I'm looking here, I know if I'm looking for complementary angles, I need two angles that add up to equal 90 degrees. Well, as I look, I notice that this angle right here is 37 degrees, and this angle is 53 degrees. Together that adds up to be 90 degrees. They are not adjacent to each other, but they're still complementary because they add up to 90 degrees. So when we're naming a pair of angles, okay, that means we need to name two angles. Well, the first angle, the 37-degree angle, is angle CAB. We could also call that angle BAC. And the other one that makes the complementary angle is that angle 53-degree angle over there, which is angle RST or TSR. Next, let's look at supplementary angles. Again, it's asking us to find a pair of supplementary angles. So let's look. We need two angles that add together to equal 180 degrees. So I have 127 here, and I have 53. Again, they're not adjacent to each other, but they add up to 180, which makes them supplementary. So our pair is going to be angle CAD and angle RST. If we are thinking about angles that are adjacent to each other, that means they share a common side. So we're going to look at this diagram right here to look at our adjacent angles. Those two have AC coming out of the middle, which means they are adjacent to each other. So we would say that angle CAD and angle CAB are adjacent to each other. They share a common side. And again, notice when I'm naming these angles, I'm using 3 letters each time, and the vertex is the middle letter. Okay, so let's look at a couple of examples using some vocabulary here. It says angle 1 is a complement, there's our keyword complement, of angle 2. And the measure of angle 1 equals 62 degrees. Find the measure of angle 2. So complement tells me that they are going to add together to equal 90 degrees, which means the measure of, I'm going to write an equation here, the measure of angle 1, I'm going to write it all out with all of our work, plus the measure of angle 2. Those two angles are complementary. They add to equal 90. Well, then I'm just going to substitute in what I know. Well, it tells me the measure of angle 1 is 62 degrees. So I'm going to take out 62 degrees, or the measure of angle 1, and put 62 in its place. 62 plus the measure of angle 2 equals 90. And then all we have to do is subtract 62 from both sides, and we get the measure of angle 2, oops, I'm running out of room here, equals, what is that, 28 degrees? Okay, we're going to do something very similar to that down here below. It says angle 3 is a supplement. That tells me that they are going to add together to equal 180 degrees. And we have angle 3 and we have angle 4. Okay, so what I want to do is we are going to show every single step. Moving forward, we want to write our equation, show our substitution, and then solve it. As we move forward into proofs in our next chapter, we are going to have to show all of these steps, and eventually we're going to give them reasons, so we have to show all of these things. So we would have, there are two angles. We have, and that little m just says measure, the measure of angle 3 plus the measure of angle 4 equals 188 degrees. I know that because it tells me it's the supplement. I know the measure of angle 4 is 47 degrees, which means I can take out angle 4 and put 47 in its place. So I would have the measure of angle 3 plus 47 degrees equals 180. Now we can just subtract 47 from both sides and get that our measure of angle 3 equals 33 degrees. Okay, so take a minute, pause the video. I want you to kind of go through this process again. It's just practicing the same thing that we did previously, naming a pair of complementary, a pair of supplementary, and a pair of adjacent. So if we look, complementary again means they need to add up to equal 90 degrees. Well, I noticed that this 49 degrees and 41 degrees add up to 90 degrees, which means my pair of complementary angles is angle F, G, K, that angle right there, and angle G, K, L, which is that angle I just highlighted in blue. Next, I'm looking for a pair of supplementary angles. Well, the first thing we might look at is this right here, where it's line FH, which is not actually a line. That is not a straight angle, because if you notice, 41 and 121 degrees does not make 180, so that is not a straight line. So now I'm going to look at my diagram and say, is there any pair that does add up to 180 degrees? Well, if you notice, 49 degrees and 131 degrees, excuse me, adds up to 180 degrees. So I know that those two are supplementary angles. So I can say angle HGK, that's the 131 degree angle, and angle GKL add up to 180 degrees, which means that they are supplementary. And last but not least is a pair of adjacent angles. Well, if I notice, I have FGH has a ray coming out of the middle of it, which means those two, that 41 degree angle and the 131 degree angle, share that common ray, which means they are adjacent to each other. So I could say angle FGK and angle LKG, and that one would make adjacent angles. Okay, so now we just want to read through this story problem, pick out what we need to know, and figure out what kind of equation we need to set up. It says angle LMN and angle PQR are complementary angles. So we have some keywords in here. They're complementary angles. that right now should be telling you ding, ding, ding. They should add up to 90 degrees. And it says find the measure of the angles when the measure of LMN equals 4x minus 2 and PQR equals 9x plus 1. Well, those are our two angles that we were given, and I know that they're complementary, so I know that my two angles, when I add them together, are going to equal 90 degrees. So to write my equation, I would say 4x minus 2 plus 9x plus 1. And again, that is using the angle addition postulate that you learned about yesterday. They add together to equal 90 degrees. You can take a minute and solve for x here. We get 13x minus 1 equals 90. If we add 1 to both sides, we get 13x equals 91. And x equals, what is 91 divided by 13? 7. Okay, but it doesn't ask what is x, it's asking the measures of the angle. Well, I know that the first angle, LMN, is 4 times x minus 2. Okay, so I'm going to take out x, put 7 in its place. 4 times 7 minus 2 is 28, minus 2 is 26. So the measure of LMN, the measure of LMN equals 26. And the other angle is 9x plus 1. So we know we take out x and we say 9 times 7 plus 1. That's 63 plus 1. So we know the measure of angle PQR equals 64. And if you did these correctly, since they're complementary, they should add up to equal 180, or excuse me, to 90 degrees. And 64 plus 26 equals 90 degrees. So that's good. All right, and then the last couple of things here, we have linear pair and vertical angles. Linear pair is a lot like a straight angle. It's just adjacent angles that together make a straight line. So you have a linear pair is going to be this straight line, and these two angles that are adjacent to each other are going to make a linear pair. Base of linear is line. Pair is, so it's telling you it's two angles that make a line. And the other one is vertical angles. Two angles are vertical angles when their sides form two pairs of opposite rays. I always describe vertical angles as they are across from each other. So in this diagram here, angle 4 and angle 5 are vertical angles. And then angle 3 and angle 6 are vertical angles. And a very key piece of information that you need to remember is that vertical angles are congruent to each other. So we could also write down here, say that angle, let's get a pen here, angle 3, the measure of angle 3, equals the measure of angle 6. The vertical angles are congruent or equal to each other. We could also say the measure of angle 4 equals the measure of angle 5 because they are vertical angles. So let's just do a quick example here. It says two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. Okay, well, let's look at some keywords here. We have a linear pair. So it tells us we're making a diagram that's going to make a straight line, and there's going to be a ray coming out of it. We have these two angles that are making a straight line. It's called a linear pair. And it says one of the angles is 5 times the measure of the other. 5 times means you're multiplying by 5. So if we look here, if this angle right here is x, the other one is 5 times that, which would be 5x. Now we have two algebraic expressions for our angles, which means if it's a linear pair, we can add them together, and they're going to equal 180 degrees. If we combine our like terms, we get 6x equals 180, x equals 30, which means this angle right here would be 30 degrees, and this angle right here would be 5 times that, which is 150. And if we did it correctly, they should add up to 180, which they do. Now, once you have finished this, you need to check in with your teacher, show her that you have your notes all done, ask any questions that you need, and then there's a homework assignment in Big Ideas that will be due tomorrow. Have a great day.